Hello all. I welcome you all to the day 2 of our FDP on PLC programming. We will wait for another 5 more minutes. We have 55 participants and there are a few more to arrive. So we will wait for another 5 minutes and then we will start.
Okay, sir. I shall start.
Yes, sir. You can go ahead. Before that, I would just want to thank all the participants for submitting their homework and assignments.
Sure, sir.
Thank you so much. And if you have any doubts, please post it in the Q&A session, and we will take it up at the end. Thank you so much, sir. Over to you.
Thank you. Good afternoon. I hope everyone has made this program and has submitted it also. Some people had sent me in WhatsApp also. Very good. They made it correct. And I have heard that many people have sent through email also. That is good. So this is the program yesterday I had given you. Pump 1, pump 2, red and green. We had 4 outputs. Here I have taken Q0 for pump 1, Q1 for pump 2, Q2 for red, and Q3 for pump green actually. Yes. So 4 inputs and 4 outputs we have taken here, and we have followed the steps. First we should make a truth table. Then we should go to the first output, should take a coil. So you should not be worried about all the outputs all together, and you should start with the first output that is Q0 here. So we should take coil of Q0 first. Then we should check the true condition of Q0. As Q0 is getting on twice, if you see the truth table, in first true condition of Q0, we have this status 1 0 0 0 of input, and in second true condition of Q0 we have 0 0 1 0, and you understand here 0 means NC, 1 means NO of input we have to take. Okay, fine. So like that we have to take all our outputs separately. Let me show you one thing. Here, this one, this example I had given you, and here also we have to follow the same thing what we had followed yesterday. Now you see, sometimes I have seen what people do. They start from input like I0, I3, like that they start from input and they take multiple coils and they repeat coil address also. That will be wrong. So we have not to start from input. We can start from input, but we get confused in that way. So better we start from coil and we shall get correct solution. This is wrong actually. What I'm showing you on screen is wrong solution for yesterday's example. And this is the correct one. So this one is the correct answer. You have made visualization also. I have shown you here. We have here visualization. This one. So red, green, pump 1, pump 2, and I0, I1, I2, I3 we have. So as we do log in, run, we press start button. That is I0, you can say. When we press I0, pump 1 and red we have on. Off this. I1, pump 2 and red. Off this one. I3, I0, I1, I2 actually. I2, pump 1, pump 2 and green. And when you press I3, all will get off. Okay, fine. Let us proceed. Let it be like this. Now, today also we have to go through many new topics, and we have to make program also for that. So we will have to start from this one where I have shown you In all our examples yesterday, how many? I think 3, 4 we made. In all examples, we have used toggle switch. This is important to understand. In all our examples, we have used this kind of switch that we use at our home also, toggle switch. Toggle switch has one property. When you press the switch at your home also, you have to get the lamp on or fan on. You press the switch. As you press the switch, switch is on, lamp is on, but you're not going to press the switch, you will leave it also. Okay, leave it. So when you leave the switch, toggle switch, it holds its position, correct? When you switch on, you press the switch, switch is on, and when you leave the switch, it will retain its position. It will be continue on. So yesterday we made program where switch is continue on, and when switch is continue on, output also we get continue on. But in industry, most of time for on and off, you won't get toggle switch, but you will find push buttons. Here I have tried to show you, this is the physical existence of push button. This green color is NO type and red color is NC type. So when you have a push button has a spring system inside it. It doesn't matter whether red or green. It will have one spring, correct? When we press this push button, so when you press the push button, you will get signal high, you will get continuity. Your motor will be on. Suppose we have one push button, one motor. You press the push button, your motor will start running. But you are not going to press the push button for long. You are going to leave it also. So as you leave this push button, due to spring system, its contact will be open, correct? So push button will not give you continue signal. Toggle switch has given us continue signal when we leave it. But in push button, when we leave the push button, it will restore its position. It won't retain, but it will restore. So your push button is off. As this push button is off, your output will be off. So here you see, this one you see. You should see this one. This one. I0, Q0. I0, suppose we have a push button here and Q0 is a motor. So when we press the push button, it is on. Push button is on, motor is also on, but it is like we have pressed it. When you press it continue, motor will run continue, but it is not like you are going to press it continue. You leave it also. As you leave this, you see, I will show you here. As you leave it, this will get off. So when you have this program for push button, it would be wrong. It is okay for toggle switch. This is okay for toggle switch. This program will not work for push button. I hope you understand. Now we come to this one. If this program is not correct for push button, do we need to make another type of logic for push button? I think it's okay. You go through toggle program, you make program toggle using toggle switch, and you make one small modification and it will be converted to your push button program. That modification is called latch. That modification is called latch. So what we have to do, we have to make a latch here. Now you see how we have to make latch. You have this input here, you see, you have this input here. Just a minute. You have your input here, this is the push button, and this is your motor. So what you do, parallel to your push button, parallel to your start button, you take one contact. Parallel to your start push button, you take one contact. And that contact will have output address. Okay, let me explain this diagram first. Here we have taken I0, Q0, and parallel I have taken here I1. If it is I1 here, I0 and I1 in parallel, it would be parallel contact. We can call it parallel contact. Yesterday we made OR gate, that kind of thing we have here. But here when we come I0 and parallel, you see what do we have? In parallel we have Q0. Can you see this? Q0. So here you see you have I0 and in parallel you have input address. You have I1. This will be called, this we call parallel connection, parallel contact. But here, if in parallel you are taking, you take Q0, you see, if you take the coil address, it will be called latch. So here, once more, I0, Q0, and in parallel you have Q0 only. You have no I1 or other things. So when you take output address in parallel to input, it will become a latch. Once more. Wait. See this. So in this way, you will have to make modification. You have to take a latch to hold your output. If you will latch this, your output will be continue on. How will it be continue on? I shall tell you. See this one now. One by one, we shall proceed. Here, I told you this we can make for our push button. If we have push button, we have to make program like this. We have to make a latch. Okay, we have made latch, but how will it work? Here is your push button, I0. Here is Q0, and here is also Q0. When you press I0, see this, when you press the push button, I0 gets on, this one you see. When you press this push button, I0 gets on. As I0 is on, this main supply will reach to Q0. As this Q0 is on, we have the same address here, correct? We have the same address here. As this Q0 is on, this will also get on. And as this is on, you will get one parallel supply to this Q0. So now you have two paths. One you have from the push button, one path is through the push button, and another path we have from this parallel contact, that latch, you can say, from latch. So now Q0 is getting supply, this virtual main supply, through I0 push button and from this latch also. So now you have two paths to get this Q0 on, this motor on. Now leave this push button. Okay, now we leave this push button. Here you see, we leave this push button. As we leave this push button, due to spring it is open, means we won't get I0 anymore. So I0 gets off. Can you see this? I0 is not on, I0 is not blue here. So push button is off, your I0 contact is off. This path is not active now. Upper path is not active. But you can see, still you are getting supply through this parallel path to this Q0. So this is your latch path. This is your latch path. So now push button is off, but your motor will be continue on. Okay. What I want, you should understand it once more. Okay. Forget everything. If you have any doubt, you forget that. We shall learn it once more from scratch of latch. Here you see, this is your latch program. I hope you understand this. When you take output address in parallel to your input, it will be latch. So this is your latch program. Now, how will it work? That we have to see. So you can see initially nothing is on, correct? No, I0 is not on, latch is not on, output is not on. So initially nothing is on. Now we go to the machine and we press the push button I0. As we press, what happens? We have to check. This is the main supply. As we press I0, this I0 contact gets high. As this I0 contact is high, this main supply will proceed and will reach to Q0. As this Q0 is on, then only your latch will be active because you have the same address. Initially, this latch is not on. When this Q0 is on, then only this latch gets high. As this latch is high, this contact is high. Now this parallel main supply will proceed and will reach to Q0. I hope you understand. So now you see you have two paths. One path is from this push button because push button is pressed now. Another path is from the latch. So you have two paths, from push button and from latch. Now what we shall do, we shall leave the push button, correct? Now we shall see this. Now we leave this. You can see this is open, correct? No, this contact is open. As this is open here, I0 is not on. This path is not active, correct? This path is not active. This path is not active. Upper path is not active, I0 path. But no problem. I0 is off, no problem, because still we have this parallel latch path active. That's why your Q0 is continuous. I hope you understand up to this. Okay, fine. So what we understand up to now? We understand that if we want the coil continue on, we must latch this coil, correct? If we have a push button and we want our motor continue on, motor must be latched, and this we are doing in software, not any physical latch. We are going to make a latch in our programs. Okay, we understand we have to make a latch. But there is again one problem. The problem is, once this is latched, Q0 is continue on, you cannot switch off this Q0 from I0. Now you don't have control to switch off this. Once this is latched, will be continue on. You will not be able to stop your motor. So again, one thing will come. If you have made a latch in your program, you must have one NC to break that latch. If that latch is not broken, your output will never get off. So remember two things about latch. If you want your coil continue on, latch it. And how do we make a latch? Here you can see, correct? No, here you can see we make latch like this. Another thing, if you have a latch, it must be some NC to break that latch. What is the address of that NC? It depends on your condition. So you must have one NC to break this latch, then only your output will get off, or else it will never get off. Now, how will it make it off? You see, I have taken here I1. You have seen, no, you will have two push buttons, I0, I1, all the time. So this I1 I have taken here, signal to break this latch. So when I1 push button is high, this NC will break the path. As this NC will break the path, this Q0 will be off. As this Q0 is off, latch Q0 is also off. So finally everything is off. I hope you understand. So latch is very important. From now onward, we shall use push buttons. Toggle program, we stop it. So we must have one latch if we have a push button in our program. Or you can say, if you want the coil continue on, you must have a latch. And if you have a latch, you must have one NC to break that latch. Okay, fine, let it be. Don't complicate. Now we shall proceed. Now here I come. Better I show you from this screen something. Wait a minute.
So you can use that widescreen option also.
We have there.
Yeah, on top.
Just a minute. This one, huh?
Sir, I think it's adjacent to the annotate button itself on top.
Right. Better I use that one as well.
Sure, okay, all right.
Okay, you see here. So we have taken latch. Now the thing is, we have to add latch in our previous examples. I shall take one example that yesterday you have made. NO, NC, NC, correct? And we had one more NC here. and a coil. Q0, that is your pump 1. So I0, I1, I2, and I3. Correct. You have to tell me, if we have to convert this toggle program into push button program, what should we do? Obviously, you will say we have to make a latch. If we have to get this output continue on, as we have push button here, all these are push buttons, we will have to make a latch. But how shall we make a latch? So often I have seen that people say, we make a latch like this, and here it would be Q0. Obviously, latch will have that output address. Fine. But there is one issue here. If we have a latch, this is your latch path, correct? No, this one is your latch path. If you have a latch, it must be some NC to break this latch. So you can take one NC here, or you can take NC here also, no problem. In this latch path, you can break it anywhere. If you have one NC, you will have to give one address also. Without address, your program won't function. So now this is one problem. If we take one NC to break this latch, what address we should use here? Some people will say we have to take I4 because up to I3 we have already used. But you cannot take I4 because client has not given you 5 inputs. Client has given you only 4 inputs. So you can use up to I3 only. I4 if you use, client will have to purchase one more push button, and that push button will cost 300 to 400. So for all latch break, you cannot put one new NC address, new input address you cannot use, because input address has physical existence, output address has physical existence. So your NC address must be from your program. So you cannot take here I4, you cannot take. So this is wrong. Then what we can do? We can do one thing, you see. Remember how we can make a conversion. To convert toggle program into push button program, take latch of output below each NO contact. If you remember this, it would be very easy. I shall show you, don't worry. Once more, let me repeat. To convert toggle program into push button program, take latch of output. Take latch of output, whatever address you have in your output. So take latch of output below each NO contact. Below each NO contact. Now let me show you here. I have already made this. Here you see. This one you see. That I had shown you. Here, this one is not correct. Why? Because you have taken here one new address, correct? And you have many latches you will have to make in your program, and you can't use new button all the time. So now you see what I told, to convert toggle program into push button program, take latch of output. What is output here? Q0. Take latch of output below each NO contact. Here is the NO, correct? Here we have NO. So below NO we have taken a latch, and you can see already we have 3 NC contacts here to break this latch, correct? This is your latch path. You can see this is your latch path, and already you have 1, 2, 3 NC contacts to break this latch. But it is not over, because in this network you have one more NO contact, that is I2, isn't it? I2. So you must take this latch here also. So you take latch of output below each NO contact. I hope you understand. So here also you see this is your latch path. This is your latch path. And already 1, 2, 3. And this NC, it can be before or after latch, it does not matter. So I hope you understand latch. To convert toggle program into push button program, take latch of output below each NO contact. Okay. It is finished. We shall proceed. We have to learn other things, many other things. Fine. Here I have shown latch of that blue, green, red program we had made yesterday. Leave it. We shall go here for flag. Now your important instruction is flag. So let me tell you that basic example yesterday I told you, that we can make from truth table, the steps we can follow and we can make program. Today, we have to forget that. We have not to use truth table. That was for basic examples. Now we are going to learn how we can make program for any machine in industry where we have PLC. So now we shall learn the program to make program for any machine having digital input output. Analog programming we are not going to learn. Digital input, digital output we are going to learn. Okay, fine. To make program for a good machine, you need to learn some more instructions. Very first instruction for a good program is flag. Flag is very important. Further, I shall show you it is that important that you cannot make good example, or you can say industrial example, without flag. Flag is that important. Flag is very important. First thing, what is this flag? Flag you have studied in your college also. Carry flag, parity flag, status flag. There are many types of flag. In PLC also you have flag, programming part. Let it be any type of flag. Its a definition we can have the same. Like flag is an internal bit memory which has no any physical existence outside of controller. Once more. Flag is internal bit memory, and bit memory. Bit, do you understand bit? Bit is the signal which is either on or off. We have two states only for a bit. It will be either on or off. Yet we have gone through input bit, that is I0, it is on or off. We have gone through output bit, that is on or off. Now flag is also a bit which will be on and off. So flag is an internal bit memory which has no any physical existence outside of controller. It means flag has no physical existence. Outside of PLC, there is nothing flag. If I say input I, it has physical existence. First physical existence is I0 terminal. Another existence is push button, selector switch or sensor, whatever. If I say Q0, it is also a bit memory, but it has physical existence. Q0 has one terminal outside of PLC, and it has physical existence, motor, relay, contactor, whatever. Now flag is a bit memory, but it has no physical existence. Remember this, it has no physical existence. If we use flag address in our program, there is nothing outside. Flag is nothing outside of PLC. So it will support your logic. Okay, this you understand the definition. So it is an internal bit memory which has no any physical existence outside of PLC, correct? Flag is an internal bit memory. Fine. Now, as I told, input is a bit memory, flag is a bit memory, output is a bit memory. In Coil, do you know, in Coil we can use only output address. In contact, we can use any bit address. Means in NONC, you can use any bit address like input, output, flag. All three can be used in NONC, in contact. But in Coil, yet we have used only Q address. I we cannot use in Coil. From now, we can use flag address also in Coil. So in Coil, we shall use two addresses, either output address or flag address. So here you have something similar, you see. Flag is a bit memory, output is also a bit memory. In Coil, we can use output, in Coil, we can use flag. So these two are similar, very similar. Both are bit, both we can use in Coil. So the question will be asked, what is the difference between output and flag in that case? Where we have to use output, where we have to use flag? Difference, you understand? The difference is, flag is a bit memory which has no physical existence outside of PLC. So if you take a coil and you take M, generally it is denoted by M. If you take M0, outside of PLC, if this coil is on, M0 coil is on, M0 is high, there is nothing outside of PLC, there is nothing M0. But in your program, if you have taken Q0 output address and this coil is high, outside of PLC, your Q0 terminal will get high and connected output will get high. If you have one lamp, motor, fan, whatever, that will get high. That will get high. I hope you understand. So flag is internal memory, output has physical existence, flag has no physical existence. This you can answer. So flag has no physical existence, output has physical existence. This is the difference between these two. Okay, now the question is, where we have to use flag in our program? Remember this. To store temporary bit signal, we have to use flag. I shall explain it, don't worry. To store temporary bit signal, we have to use flag. I shall explain this with one example. So where we use, when we use flag, to store temporary bit signal, we have to use flag. Okay. Now let me explain its importance and use with one example. There is one timer, suppose. Timer we shall learn just after this. Don't worry. Suppose we have one on delay timer. On delay timer needs continuous supply to run. Be very clear about it. On delay timer needs continuous supply to run. So you cannot run one on delay timer by a push button because push button is not continue on. Another problem, we cannot latch a timer. We cannot latch one on delay timer. So if you think that we will latch the timer and from push button we will run, it is not like that. So on delay timer runs from continue signal and we cannot run this by push button. An example, try to understand. Suppose you go to one interview. And in interview, one question is given. We have a push button I0 and we have one timer on delay. When we press I0 push button, this on delay timer should run for 15 minutes. I hope you understand the question. Once more, the question is, press push button I0, one on delay timer should run for 15 minutes. Now you see, you have to run a timer from push button. Push button we are not going to press for 15 minutes, correct? No. We shall press the push button, timer should start. We will leave this push button, but timer should run for 15 minutes. So if we make a program like this, you see this program. If you make program like this, you have taken here I0. If you take here I0, push button, when it is on, timer will start running. Timer will start running, but as this push button is off, because you are not going to press the push button for long, as this push button is off, this contact is open, timer won't get signal and timer will also stop. So this program will be wrong. This program is wrong. Okay, no problem. Then how can we make this? And you see, you can't use you will say that we shall take I0, we shall latch one Q0 and from Q0 we shall run the timer. It is not like that in this example, because in this example you have been given only one push button and one timer. They have not given you any output or other things. So you cannot run this timer from a push button. You can say now it is impossible to make this program with the push button. To make it possible, you have flag. How you see? In this example, I0 is a push button. Don't see that program. You just listen to me first. In this example, I0 push button is not continue on. That is one temporary signal, correct? No, I0 you press and leave. So I0 is on for one duration, short duration. It is temporary. It is not continue. I told you, to store temporary bit signal, we use flag. So we can store this I0 temporary signal in one flag, correct? And that flag we can give to the timer. Let me show you here. Here you see, I0 we press, that we store in M0, but it is not continue on until you latch it. You see, we have made latch also here. So I0 on, what will happen? You have to tell me. I0 on, what will happen? M0 will be on, correct? As M0 is on, because of latch, M0 will be continue on. Now, this I0 is off. Now, push button you leave, no problem. As M0 is on, you can see the signal will reach to this timer enable. And this timer will start running and it will keep running for given duration, no problem. What will happen after 15 minutes? You don't think, please. That we shall learn in timer. You don't think what will happen after 15 minutes. Here I have shown you the importance of flag. Without flag, this example you cannot make. So flag is very much required to store temporary bit signal. I0 is temporary signal. We have stored that in M0, and from M0 we have run the timer. And there are many instructions where without flag we cannot make up program. So it supports our logic. I hope you understand flag. Fine. Now we shall come to the timer. Don't worry, we shall understand flag with the timer example. It will be very much clear. The concept I hope you understand. Timer, you see. Timer, I think, is the most important instruction. Timer is the instruction from which one system becomes automatic. If I say automatic system, what does it mean? Automatic system means, I think so, and not only I think, but this is the thing. If you have one machine having many outputs, you can have motor, you can have pneumatic system, hydraulic system, you can have lamp, router, there are many things. So in one machine, you have many outputs, and we have to make it automatic. Automatic means what? It means when each and every output of your machine will get on itself, correct? No? And will get off also itself without involvement of one man, human. That will be automatic machine. When each and every output of your machine will be on itself, will be off itself without involvement of any person, any human, that will be automatic machine. In very simple, I have told you. Definition you can have it. Now let me explain this with one system. Here I have tried to show you. We are having one drill machine. Just imagine this is one drill machine. It is not the exact one. This is the workstation where we have put one metallic job. There is one metal in which we have to make a drill. So we have put it here. So one man will come and will put this. This is manual operation. When this jog is put on the workstation, one operator will go and will switch on valve 1. Suppose this is to filter dust. It is air valve. Suppose this valve should be on, and this valve should be on for 3 seconds. Suppose. So what will one operator do? Operator will go, will switch on one switch. Now valve is on and we'll see his watch. 1, 2, 3. We'll go and we'll switch off that. Now we'll go for another valve. We'll switch on. It should be on for 5 seconds. Suppose again he will monitor. Okay, 1, 2, 3, 4, 5. We'll switch on. Next should be on. We'll switch on, and again we'll monitor the watch, and he will switch off that output, and then we'll start drill. But obviously, it won't be one accurate system, and it will not be fast system, and it is so boring task also for one operator. One operator full day cannot do the same thing. So now let us make this system automatic. How we can make this? We can convert it in automatic system. Let us do some modification in our machine. Now, as this job, metallic job is placed on this workstation, we have used here one proximity sensor, metal detector, 3-wire. That I shall explain further. So we have one job detector here. So as you put this job on workstation, obviously some input you will get. That suppose we are getting I0. A job will be on this sensor continuously. It is kept on the sensor. Sensor will be continue on, so no need to latch. Continue I0 you're getting. As you get I0 on, V1 should get on for 3 seconds. So what you will do, from I0 you will switch on Q0, and one timer also you will run for 3 seconds. After 3 seconds, timer will give you one signal that is called done bit, and that done bit NC will break this first valve, and anode of that done bit will switch on another valve, that is V2. As another valve is on, start another timer for 5 seconds. As 5 seconds will get over, automatically its done bit NC should break valve 2, and done bit NO should start another output, and again one timer will be used. So you can see, most of time with each output, one timer will run to operate it on and off automatically. So timer plays major role in automatic system. Now I come to the timer. This was just one example. Now I come to the timer. Here you see timer. Timer we have of 4 types. In Codis software, let me tell you. And one important thing, let me tell you about Codesys. Codesys software we use for Mesung PLC, MESSUNG, Mesung. Mesung is Indian brand. Now it is overtaken by Mitsubishi. But the software is used for Mesung PLC. So this you should know. Mesung, MESSUNG, Mesung. In Codesys software, we have timer of 4 types. On delay timer, TON, off delay timer, TOF, TP, pulse timer, RTC, real time clock. On delay timer, off delay timer, pulse timer, and real time clock. Okay, proceed. But these 4 types you won't find in all brands of PLC software, I have seen. But in all brands, you will find on delay timer. So on delay timer is most important. It is available in all PLC brand software. I have made program for many machines in industry, and yet I have never used this off delay timer or pulse timer. With on delay only, you can make all examples related to delay. So on delay timer, we are going to learn here. Further, you have the software, you can learn this on these off delay and pulse timer also. But on delay timer is most important for any automatic system. So I shall explain on delay timer here. Here you see. Timer will have 4 parameters. This is the timer. This is the timer. Timer will have 4 parameters. Let me explain you. Let me explain this. So timer has 4 parameters. 1, 2, 3, and 4. This one you see. This one. This is your enable bit. This is your enable bit. So this is enable, EN, or name can be different. IN also sometimes you will find that is equal. EN. So this is EN, enable bit. This is PV, preset value. I shall explain what we have that. This is ACC. ACC, accumulator. This is DN, done bit. DN, done bit. So timer will have 4 parameters: enable bit, preset value, accumulator, and done bit. Now what we have all these things. Enable bit is the signal from which timer starts running. Enable bit is the signal from which timer starts running. And for on delay timer, this enable must be continue on, correct? Enable bit is the signal from which timer starts running. As enable will be high, timer will start running. And this enable must be continue on for on delay timer. Next, PV, preset value. Preset value is the set point. How long you want to run the timer, you need to mention there, isn't it? If you have to run your timer for 10 seconds, suppose, you need to mention there 10s. If you have to run for minute, 10m, millisecond, ms. So they will give you format, you have to just follow. So preset value is the set point. How long you want to run the timer, you need to mention there. Then accumulator. Accumulator is one register actually, but let me explain this in simple way that you will remember for now. Accumulator in this timer is a display actually. Accumulator, when you will see this in software, we shall practice it also. When you will see this accumulator location is one display where we monitor the running value of timer. You can say the present value of the timer. So as enable is high, timer will start running. So you want to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That running value you can monitor on accumulator. So it is one display. Done bit. Done bit is the confirmation signal of the timer. Done bit is the confirmation signal of the timer. See, you have given one task to this timer that run for 10 seconds, for example. As it will finish 10 seconds, correct? No, as timer will finish 10 seconds. What does it mean? When accumulator will be equal to PV, correct? Initially accumulator was 0. As enable is high, accumulator will start running and it will reach up to your preset, whatever you have given. So as your accumulator is equal to preset value, your done bit will be high. Once this done bit is high, from this done bit anno you can switch on something, correct? Suppose after 10 seconds we have to switch on something. How shall we? After 10 seconds we get signal done bit, and that done bit address we can use as anno to switch on something. After 10 seconds, if you have to switch off something, take that done bit NC and switch off something, correct? It's very simple. Once your timer will give you done bit, you can perform your next task. Wait, let me show you. Let me show you when it will run, how will it look like. I hope it is visible to all clearly. So here you see, this is your I0 push button. For on, I1 we have taken for off here actually, that stop button. M0, we have stored this I0 in M0. From M0, this timer will run and done bit will come. Here you see, this you need to understand. In Codesys software, they have given one coil as the done bit, correct? They have given one coil as done bit. If we have coil, we can use either output address or flag address. It means here you can use output address also. But I suggest you never use output address as done bit. Always use some flag. So output you keep separate. Don't use output everywhere. So here, always use some flag. That's why I have taken M1. I have taken here M1. Fine. Now we shall run this. See this one. This one you see. Better I show you this one. As this I0 is pressed, it is pressed in this example. As I0 is pressed, it is left also, no problem. M0 is latched. As M0 is latched, is continue on. As this M0 is continue on, you see enable is high. As enable is high, it will start running. It will start running. And here you can see it will start running. So 1, 2, 3, 4, 5, 6, it will start running. As you can see here, as accumulator, what do we have in accumulator? 15 seconds. Can you see this? 15 seconds. And what do we have in preset value? 15 seconds. So you can see Accumulator is equal to preset value, isn't it? Accumulator is equal to preset value. It has finished 15 seconds. As 15 seconds over, you get this done bit high. Can you see this is blue? So M1 is high. M1 is the done bit in this program. Can't we say this M1 is after 15 second signal? This M1 in this program, this M1 is after 15 second signal because it gets on after 15 seconds. So after 15 seconds, if you have to switch on something, take M1 NO, switch on something. After 15 seconds, if you have to switch off something, take M1 NC and switch off something, isn't it? So it's very much clear. And another thing is, once this done bit is high, accumulator is equal to preset value. We can say the timer got set, correct? No, timer got set. Now it is in saturation. It won't proceed counting further. It is saturated, it is set now. Done bit is on and accumulator is equal to PV. We need to reset it also. If we won't reset, it won't run in next cycle. So to reset on delay timer, break its enable. To reset on delay timer, break its enable. Simply, you have to break this enable. Either you break here or you break here. As you will press I1, this latch will be broken, M0 will be off. As M0 is off, it will become reset, means it will be 0 and this will be off. Correct? No, reset means done bit is off, accumulator is equal to 0. So two things you remember while making program for timer. Timer, on delay timer needs continue enable, continue signal to run. And to reset, you need to break the enable. Simple. To run the timer, give it continue enable, and to reset, break it enable. Simple. Okay, we shall go for some programming. So here it is reset. No, off delay timer we are not going to learn. RTC, TP we are not going to learn. Okay. Now it's your task. Now we shall practice some examples, and it would be so interesting. If you are able to make timer program, you can consider that now somewhat you are a programmer. Although PLC programming is a large subject, you have to learn a lot. But the base from where you can go for next level, that is up to timer. If you know to make program up to timer, you will be able to make program for digital input output. Any machine where you have digital input output. So before starting this timer program, let us revise the important point, what we have to remember while making program. So I have written it here also. Important programs, points actually. First one, to switch on, use NO contact. Yesterday we have seen, correct? To switch on, use NO contact. Always to switch on, use NO contact. And to switch off, use NC, correct? To switch on, we have to use NO. To switch off, we have to use NC. Next, this you need to understand. This is important. Whenever we have start signal, like I0 push button. So whenever you see you have one start signal, latch that with some flag. This is not a rule. There is no rule, right? Everyone will make program in different way. But we have to learn programming in the easiest way and in short time. So better you remember this. It will help you to make program in simple way. Whenever you see in your example, you have some start signal. Immediately you latch that with some flag like M0, M1, whatever. So when we have start signal, we have to latch that with some flag. Always remember. Next, when we get stop signal, obviously in your example, somewhere you will find, okay, when this signal comes, we have to stop the things. So whenever we have stop signal, from that we have to directly break the latch. So two things. When we have start signal, we have to latch that with some flag. When we have stop signal, from that signal we have to directly break the latch. I hope it is clear. No problem. Further we shall use this also in program and will understand. Now I give you one example. This one. Can you see this example number 11? We have a push button I0 and a motor Q0. Try to understand. Huh? We have a push button, not toggle switch. You forget toggle switch. We have a push button I0 and we have a motor Q0. Mechanical people, you can consider one single acting pneumatic cylinder. Single acting pneumatic cylinder will also work by one output. So remember this, you don't need to be worried about the physical existence of output, whether it is a motor or it is a pneumatic cylinder, hydraulic cylinder or anything else. While making program, address is required. What is the address of output? That is required. So here I have written, we have a push button I0 and a motor Q0. The example is, the requirement is, press I0 push button and motor Q0 should get on for 10 seconds. So press I0 push button, motor will start and motor will run for 10 seconds. What does it mean? After 10 seconds, it will be off automatically. You have not to switch off. It will be automatically. So try to make this example. Try this on your own first. And this is on your screen. You can see the important point. This you have to make in your notebook actually. Don't use software. Make this program in your notebook. I0 on, Q0 on for 10 seconds. Simple. Try this. For 1 minute, you have a try. Is it done? Is it done? Okay, you can check your solution with these solutions I have given here. See this. How have you made? Check. Is it similar to this? This one? Some people, if you have made program first time, might be you have made this mistake. I have seen such type of errors or wrong solution in many training programs, so I have mentioned it here. Sometimes what we do, from I0, we have to take M0, from M0, Q0, from Q0 one time. It is wrong. Once you take one coil, your ladder is over. You can't go beyond this. Second one, you see. I0 on, timer is on, correct? No. But the problem is, you are not going to press this I0 for 10 seconds, correct? You will press and will leave it in 1 second or half second. So this timer won't run. When you press push button, it will start running, but as you leave, it will stop. So your program won't run. This program is also wrong. Now I come to this. Many people, I'm sure, many of you have made program like this. I0 on, make a latch, because important point you have seen. When we have start signal, we latch that with some flag. Very good. This is correct. This ladder is correct. From M0, as timer is very new for you now, you were so excited and you started taking timer. So immediately you have taken one timer. So what will happen? M0 on, continue on. So your timer will run. That is correct. Timer will run, continue, no problem. As 10 seconds will be over, what will happen? Tell me. then it will be on. After 10 seconds, then it will be on. As this done bit is on, it means Q0 is getting on. After 10 seconds, what should happen? After 10 seconds, Q0 should get off. But in this program, it is getting on after 10 seconds. Do you understand? After 10 seconds, Q0 should get off. But in this program, it is getting on, which is wrong. So this is also wrong. No problem. Like yesterday, to make the things simple, we have gone through some important point like truth table and all the steps. For such type of example, where you are making program for a good machine, there also you can follow some steps, and believe me, if you follow the steps, you will get solution. You don't need to think more, you have to just follow the steps. So again, you need to concentrate and need to learn how do we start making program, how do we proceed, and how do we finish it. I shall tell you now. See this. So these three are wrong, correct? These three are wrong solution. Now, see how I make program. How do I make program? Try to understand. Initially, when in 2007 I started making program, initially they used to give me flowchart. Flowchart, you know, right? If, else, and conditions will be there. Yes, no. So initially they used to give me flowchart in industry, and they used to tell me, okay, in this way, my machine will run. We used to make program. But nowadays I don't use this such type of flowchart and other things. I just have discussion, and while discussion, I note down the steps. If I have the steps, if I have written it correctly, I shall get solution by sure. How you see? How you see? You all have tried. Everyone has one solution in mind, but the problem is how have we to arrange the things in ladder? There we are confused, I'm sure. So that confusion, let us eliminate. But for that, you will have to follow each and every small step also. See how we make program. When I make program, very first I write down the step. See how have I written the steps? I0 on, it is not a big thing. Big thing I'm not writing. There is no syntax. I'm just simply writing how machine has to run. So I have written I0 on, see this one lay. Now you see this one, Q0 on, correct? I0 on, Q0 on for 10 seconds, correct? As this is very small example, we are having 1, 2, 3, 3 steps. After 10 seconds, what should happen? After 10 seconds, what should happen? Q0 should get off. Okay, this is not that much important now. First, we have to see these 3 steps. So you understand here. What we have to do, we have to write down the steps in simple way. I0 on, Q0 on for 10 seconds. After writing this, again, you have not to be worried about all the steps you have in your program, correct? No, you don't start thinking about 10 seconds directly. That is the last step. Why to think about 10 seconds now? Don't think about Q0 even. You start making your program from I0, first step, correct? So don't be worried about all steps. Start from first step. Let us do this. Here you see. Let us do this. So first step you see. What do we have in first step? I0 on. It means I0 is the start signal, correct? When we have start signal, we have to latch that with some flag. Important point you remember. So here is I0 start signal. When we have start signal, we latch that with some flag. This is important. When we have start signal, we latch that with some flag. This is the program for first step for I0. Now the important thing, which will eliminate your confusion. That is very important. It's very small, but it will only eliminate your confusion. What to do next? See, from I0, which signal have we got? Tell me. From I0, which signal do we get? We get M0 in this program. We get M0, correct? When I0 is pressed, M0 is on. So we have got M0. Better you write down this M0 here. Believe me, it will help you. If you won't write down this M0 here, you will be confused. So better you write down this M0 here. It will help you. Now you can see it's very much clear that from M0 we have to get Q0 on first. Correct? No, don't go to timer. This is the first one. So from M0, what to do next? Q0 on. It's very clear. So we have not to be confused how we have to switch on Q0, how we have to run the timer, what should be the enable, what should be the address to get the Q0 on. No need to think of this. You start from first step, I0 on, latch with flag. That flag you write down here. This is very important to write down here. If you will be overconfident, your program will be wrong. So, okay, from M0, Q0 on, correct? So next ladder, what you will write? From M0, this is your second ladder. M0 and Q0 you have to take. Q0 you have to take, correct? No? So this is your second ladder. I shall show you in PPT also. Fine, it is clear. Now from M0, what should be your third thing, third step? From M0, what to do next? So don't jump directly, right? No, stepwise you go. First you made for I0, then you made for Q0, then you make for timer. So from M0, what we have to do next? This timer 10 seconds we have to take. So it is very much clear that timer enable will be M0. No need to be confused. So here you see, this is your second one. I had told you, no, from M0, you have to take Q0. So here you can see, first one, I0, M0 latch, from M0, Q0 on. And according to that step, you have seen from M0, what you have to do? You have to take one timer, correct? From M0 only, you have to take your, this is the third ladder you see, ladder number 3. So from M0, you have taken a timer for 10 seconds. Obviously, you will take one done bit, that is compulsory. So M1, M0 you have used, it would be M1. M1 you got, now you see, now you see. I hope you understand up to this. Now you see. So what have you done yet? From M0, you have taken Q0, second ladder, you understand. From M0, you have taken timer, third ladder. From timer, what did you get? After 10 seconds, what did you get? M1 you got, correct? No, the done bit you got M1, I hope you remember. From timer, you got M1 done bit. I have written here. This writing M1 is important. Sometimes I see people will keep in mind M1 is there. No, you don't keep in your mind, keep it on your notebook, please. So from M1, what to do next? Q0 off, isn't it? From M1, we have to switch off Q0. And remember the point, important point. When we have stop signal, as M1 is going to stop Q0, M1 is the stop signal. M1 is going to stop Q0. M1 is the stop signal. So when we have stop signal, we directly break the latch. Do you remember? From M1, we have to break latch directly. Let me show you that. Here you see, here, this one. Got it? So this red circle you can see, M1 has broken your first latch. This is the first ladder. It has broken the latch. As latch will be broken, everything will be off. So this is your final program, you can see. This is your final program. I0 on, you made a latch. As I will show you, M0 on, latch. As M0 on, what will happen? Q0 on, correct. As M0 on, timer will start running as enable is high. As 10 seconds will be over, what will happen? M1 will be high. As M1 is high, it will break this latch. As latch is broken, what will happen? M0 off, correct? M0 off means this is also off. M0 off, Q0 off, M0 off, timer is off. It is reset. It is reset. It will become 0. Correct? Fine. I hope you understand. So what I want, you people, please write down these steps. Everyone, you write down these. Number is not required. 1, 2, 3, 4 not required. You please note down these steps. I0 on, Q0 on for 10 seconds. After 10 seconds, Q0 off. And make it fast. Write down the steps and follow each and every step. Don't skip anything. Like don't skip writing M0, M1. Now you don't write down M0, M1. While making program, you have to write down. Make this example once more. Make this example once more by following steps. Did you make this? If you have made, you can check it here. This is the solution. This is the final program. If you have not written the steps and if you are not interested to make it yourself, you can note down this. You note down because we have to practice this in software also. Is it done? Make it fast, please. Okay, we shall proceed. Once more, we shall see this important point. Everyone, see this, everyone. First one, what do we have? To switch on, use NO contact, correct? You will remember this. To switch off, use NC contact. Third one, when we have start signal, we have to latch that with some flag. That you remember, I0, M0 latch. So when we have start signal, we have to latch that with some flag. Here you see, fourth one. When we have any stop signal, we should break the latch directly from it. There is one more step I have added here. You see this one, fifth one. Fifth one you see, this one. When we get last signal in our program, from that we should break all latches. You have your program, just now you have written down the program, this 10-second program. You see that, I shall tell you to check. In this example, M1 is the last signal. In this example of 10-second timer program, M1 is the last signal. Why? Because from M1 we have not to get anything on further. Do we have to switch on anything off, anything else? No. After 10 seconds, we have to just switch off. We have not to get anything on further. So M1 is the last signal, cycle is over, you can say. So when we get last signal in our program, from that we have to break the latch, and we have broken the latch. Suppose After 10 seconds, you have to switch off Q0 and switch on Q1. Do you understand? Once more. After 10 seconds, switch off Q0 and switch on Q1. In that case, M1 is not last signal because you have to get Q1 on further. In that case, you don't break latch from M1 because M1 is an intermediate signal. Now it is not the last signal. In that case, you don't break latch, but you break Q0 ladder. You have to break Q0 ladder. That second ladder will be broken in that case, if it is not the last signal. So whenever you get last signal, then only you break latch. Whenever you get last signal, then only you break latch. So you have to remember this in next example. I give you one example. This time I shall write down the steps and you have to just follow it. Here you see, I have written the steps. I have written the steps. You just write down the steps first. Don't write down here this one. That you have to write down while making program. Make this place. Write down the steps. Everyone note down and make program for this and make it stepwise, please. We have to learn to follow the steps. If you won't follow the steps, your program will be wrong. Don't skip any step. I0 on, Q0 on for 3 seconds. I0 on, Q0 on for 3 seconds. After 3 seconds, Q0 off and Q1 on for 7 seconds. Make this place, make this place. You don't think about how I have given arrow and all. You don't see that. You just make it from I0. You start making it from I0. One by one you make. Follow the step. You have 1 minute, you finish it. Follow the step. Follow the steps honestly. Is it done? So you have to make this program. I shall tell you how we have to proceed. So first, have you made program for I0? What we have to write for I0? I0 M0 latch, correct? Then what you will get? M0. From M0, what we have to do first? M0 Q0. This is the second ladder. M0 Q0, correct? Now from M0 third ladder, what we have to do in third ladder? M0 3 seconds timer, correct? M0 3 seconds timer in third ladder. From that timer, you will get one coil, that is M1 done bit. So from 3 second timer, you got done bit M1, correct? Now from M1, what to do first? First, switch off Q0. Don't break latch. Please do not break latch this time, but you break second ladder. Q0 ladder you have to break from M1. Okay. Next, what to do from M0? From M0, switch on Q1. I think many people have skipped it because I have seen people skip it. It's very small, they skip it. So from M1, you have to take Q1. M1, Q1. Then in next ladder, it would be M1 and 7 seconds. This is the last ladder. M1 7-second timer, M2 coil you have to take. M1 7-second timer, M2 coil, and that M2 is the last signal which will break the latch. That M2 will break the latch. Let me show you here. See this one. Up to this you see first. So first ladder, here we have first ladder, I0, M0 latch. Second ladder, M0, Q0. Third ladder, M0, 3-second timer, M1 will come, correct? When this M1 comes, you have to switch off this output. So M1 NC, this is NC actually, M1 NC you have to take. Next, here you see. After breaking that, you have to take M1 Q1, correct? This is the fourth ladder. In fifth ladder, M1, 7 seconds timer. M2 you have got. As you got M2, the last signal, you have to break the latch. Here, you have to break the latch. Is it done? I hope you have made like this. So this is your program. This is your program. Okay, fine. One last example you make, then I shall give you a break. After this example, I shall give you a break. So you see this one. Actually, I have taken here two systems, different systems. One system is having one lower tank, upper tank, and mixing tank. So there are 3 tanks. You see this one, that one is another one. So lower tank has one pump, upper tank has one valve, mixing tank has one motor. So we have 3 outputs. You see, this is pump is one output Q0, valve is another output Q1, and motor is Q2. We have 2 push buttons, one for start, one for stop. As we press start push button I0, pump should get on for 10 seconds. After 10 seconds, pump should be off. Valve should get on for 5 seconds. After 5 seconds, valve will be off. Then motor should get on for 7 seconds. It is, you can say it is extension of your previous example, where we had 2 outputs, here we have 3 outputs, nothing else. So after 7 seconds, you have to switch off everything. Means after 7 seconds, latch will be broken. I1 is stop button. I1 you have to put beside your last signal. I1 will also break the latch. Your last signal will break latch. That's some flag. And beside that, I1 will also break latch. I1 is emergency off. This is manual stop. And the same thing you see here, this one. One side traffic light. Red lamp, yellow lamp, green lamp. When we press the start button I0, red should get on for 10 seconds. After 10 seconds, red is off, correct? After 10 seconds, yellow is on. Yellow should get on for 5 seconds. After 5 seconds, yellow off, green should get on, correct? This green should get on for 7 seconds. After 7 seconds, this is also off, means everything is off. You make program for this, everyone. You have already made for two outputs. This is for 3 outputs. That is the extension. You try to make this program. So we shall practice 3 examples today for timer. Make this also. Make this example. Everyone follow the steps and make this program. I0 on, Q0 on for 10 seconds.
So do we take a break now or?
After this program, if they will make, they will get break or else no break.
All right. All right.
After 10 seconds, pump is off. Valve is on for 5 seconds. After 5 seconds, valve is off and motor is off for 7 seconds. After 7 seconds, switch off everything. Don't be worried about I1. I shall show you how to take that. You make your program, what you have learned yet. Is it done? If you have made this, you can see this solution. These are the steps. I don't think that everyone has written this because it is in your mind, I think. Better you should write down this. It will help you to make programming easily without thinking anything. But all are intelligent, I know. Follow the steps, okay? And you have to make this and see this is the solution. Have you made like this? First, check up to this. First ladder you check. I0, M0 latch, correct? Here you see I1 I have taken here. I1 will simply break the latch. This is stop signal. This is M3, this is the last signal. M3 is the last signal. This is actually M3 is automatic stop and I1 is manual stop. A man will stop and M3 is automatic stop. And second you see M0 Q0. From M0 one timer for 10 seconds, 10 seconds over. When 10 seconds over, M1 will come and M1 will break this Q0, correct? Now, from M1 you have to take another output, Q1. From M1 you have to run another timer that is 5 seconds. After 5 seconds, M2 will come, it will switch off this output, correct? Now, from M1, you see, you have taken this, M2 has come, M2 has broken Q1. Now, M2 will switch on Q2. M2 will run another timer 7 seconds, 7 seconds over. M3 will come and M3 will break this latch. M3 will break this latch. Is it okay? I hope you understand. We shall take a break of 35, no, 10 minutes. And exact after 10 minutes, I shall start. And we shall practice few examples. Thank you. You can send your queries. You can type that. Thank you. We shall have a break.
Sure, sir. So the answers are there on the screen. You can discuss the answers.
Yes.
47 people have answered. Others, I think there is some issue. That's all right. See
They
it.
told that it is not visible, I think.
Yeah.
Let it be, no issue.
Yes, sir. You can discuss the answers, please.
Yeah. See the first one. Which instruction we use to get coil continue on when we use push button? So when we have push button, which instruction we use to get output continue on? That is latch, correct? Which address we don't use in coil? I told you in coil we can use output address, flag address. We can't use contact. NONC we don't use in that. Which one is not the parameter of ton? In a timer, I told we have 4 parameters: enable, reset, accumulator, and unbit. So reset is not there, correct? Reset we do by breaking enable. Okay, done.
All right, sir.
Fine, sir. We shall proceed, huh?
Yes, yes, sir. We will go ahead with the next program.
So you have seen this example just now. You have also made it. Here, I had explained that we have to start from first input. That is the first step actually, I0. And from last signal, we have to break the latch. Sometimes, in the same example, the question will be like when you have I0 on, correct? When you have I0 on, you have to get this on, correct? After 10 seconds, that is off and this is on. After 5 seconds, this is off and green is on, correct? And after 7 seconds, you have switched off everything. We have to make one modification, and this you should know. After 7 seconds, switch off green and switch on red again. I mean to say, repeat the process. So the question is, when we press the start button, red is on for 10 seconds. After 10 seconds, red is off. Yellow is on. It is on for 5 seconds. After 5 seconds, yellow is off. Green is on. Now green is on for 7 seconds. After 7 seconds, green should be off and red should get on again. And the same process should repeat. So it will be continuous process. Red, yellow, green, red, yellow, green. It will be continuous. And when you press the stop button, it should stop. So what modification we can make? How can we repeat the process? So we will have to modify our ladder. Again, we might have many solutions for any example. Let me tell you the easiest way. See this one. Number here. Remember, to repeat process, take last signal and break first timer. Once more, to repeat process, take last signal of your program and break first timer. Do not break latch. Do not break latch. Why have we not to break latch? Because it is continuous. Latch break means everything is off. So latch we have not to break, but we have to break first timer. As you break first timer, your process will repeat itself. So here you can see, here I have shown. This M3 is the last signal in your program, in your previous program. M3 is the last done bit. So from M3, we have not broken, here you can see, we have not broken this latch from M3. In previous, you have broken M3, broken latch from M3, but here we have not broken this by M3, but we have broken first timer. But how does it repeat the process? See, how does it repeat? This Q0 is off, correct? No, you have run the process. Q0 was on, it was off. Then Q1 was on, it was off. Then green got on, 7 seconds over. After 7 seconds, M3 comes. When M3 comes, what happens you see? M3 breaks this path. So your M0 will stop here because M0 is continue on, M0 is latched. So M0 will stop here. M0 stop here means enable is off, correct? This timer enable gets off. As enable is off, M0 will be off, isn't it? As once more I shall repeat. As M3 comes, M3 NC breaks this path. It means M0 stops here. As M0 stops, enable of this timer is stopped. So timer is reset. Timer reset means what? Accumulator will become 0 and done bit will be off. And what do we have here? Done bit M1. So M1 is off. Now you see what will happen. As M1 is off, two things will take place simultaneously. How? And what actually? As M1 is off, this brake will be released, correct? As M1 is off, this brake is released. As this brake is released, this M0, which is on, will reach to Q0 and it will make it on. So as first timer is broken, first timer was breaking Q0. Initially, you remember, first timer after 10 seconds had broken Q0. So as first timer is reset, its done bit is off. Done bit is off means that Q0 break is gone. So M0 will switch on Q0. At the same time, as M1 is off, M1 will get off here also, no? Here also, here also. As your second timer, you can see here, second timer enable is M1. As M1 is off, second timer enable is off. It means it's done bit M2 is off. As M2 is off, you can see your output Q2 green lamp will get off automatically. We don't need to break this. It is off. You can see there is no any NC here. So it will get off because first timer was off. Because of that, second timer was off. As second timer was off, because of that, third timer will also get off. You see, second timer is off, M2 is off. M2 is off, this output is off. M2 is off, this enable is gone, it is reset. Reset means M3 is off, correct? Now as M3 is off, you see what will happen. As M3 is off, it was broken? No, it was broken. As M3 is off, it means it is gone. You see, this break is gone, correct? As this break is gone, what will happen? Mr. May. So what will happen here? This will, as this latch is, as this break is gone, this M0 will come here and will start. So what had happened? When M1 was off, this M0 started Q0. At the same time, it went down and switched off M3. As M3 is gone, this timer is also on. So to run your process, your output and timer should run, and it will take the process forward again. So remember this, to reset break latch and to recycle break first time. To reset your program, complete program, break all your latches from last signal. And to recycle or repeat your process, take last signal, break first timer. Okay, let it be. Let us proceed. Again, we shall go through important point. If you remember these important points, you will be able to make program easily by following steps. So what are the steps? First one, you know that to switch on, use NO, and to switch off, use NC. Third, when we have start signal, we have to latch that with some flag. This you have to remember always. When we have start signal, we have to latch that with some flag. When you get next example, anywhere, anytime, you latch that with some flag. When we get stop signal, from that we have to directly break the latch, correct? Another thing, when we get last signal in our program, we should break all latches from it, correct? No, this also we have done. When we get last signal, we have to break all latches. Next, to repeat process, take last signal and break first timer. But you see, your program, every time it won't be dependent on program, correct? Every time it won't be dependent on timer actually. So in this program, in this example, where we have Q0, Q1, Q2, red, yellow, green, with each output we have one timer. So this program is timer based. It is timer dependent. So in such example, you take last signal and break first time. It will repeat the process. But you will get many examples where your program will not be dependent on program timer, but it will be dependent on many latches. In between, you will get many latches. Condition will come, it will be latched. Condition will come, it will be latched. Most of time when we have many sensors, we get such type of thing. So when you have many latches in your program, your program is not based on timer, you can say, and you have to repeat process there. In that case, break all latches from last signal, break all latches except first one. Means you don't break start latch, don't break that I0 latch, but you break all other latches. It will repeat the process. So two things you understand about repeating the process. Take last signal, break first timer if it is timer dependent. Second is, if it is not timer dependent, take last signal, break all latches in your program except first one. So that start latch you don't break, but other latches you break from last signal, it will also repeat the process. So these important points will help you actually. These will help you. Actually, we have many examples based on timer, but we won't go through that because we have to practice also. You see, I have told about this only. In this example, we have many sensors, level sensor, low level, middle level, high level. In this program now, it will be dependent on latches, many latches. There, you repeat the process, then break all latches. Okay, leave it. Few people, you have problem to not download, install Odyssey software. How can I help you in that? So better what you do, you see the screen I shall make, you make with me. I shall practice in behalf of you, on behalf of you, I shall make programming. So you try to learn from here. Further, I shall try to solve that out. So other people who have Odyssey software installed in your laptop, please open that software. Odyssey. We shall practice timer, 3 examples of timer. That 10-second and 2 timer and 3 timer. We shall practice that. And I shall tell you how to make ladder for timer and how to make visualization also. It is very interesting actually. Open Codices, please. Open Codices software, take a new file. Oh, I think you can't do this parallelly, right? So better you look at the screen. I shall show you how we make program for timer. One example you see, and then other you can make. So see this, please, everyone. So this is one ladder. You have in your notebook, right, that 10-second timer program. First example of timer. You open that. First example. So in first example, you can see I0, M1 latch, correct? No, M1 break, Q0, and I0 latch, right? Let me write down the address. What is the address of input? Percentage IX 0.0, correct? What is the address of flag? Percentage MX 0.0. You can copy this. And we have to give this address here also. And we have to give address here also. M1. Is it clear for all? You see, this is your first ladder. I0, M0 latch, M1 break. Now I shall copy paste the ladder. You see, you can click this ladder, Control C, Control V, it will come here, and I shall edit it. So here you see, this is not required, this is not required. And what is the address here? Output address, second ladder, percentage QX 0.0. See this, everyone. So two ladders I have made. Third ladder. Again, let me copy paste. Now you see, here it should be M1, right? No, M1. Third ladder you see. This is important for all. See this. I shall show you here how to take timer. Third ladder, this is the third ladder, and here we want timer. See how to take timer, everyone. Right click on the ladder where you want timer. Right click on the ladder where you want timer. So I have clicked here. Right click. Function block. Right click, function block. Here, this will be appeared. See this, left side, right side. Left side, see this, left side, right side. Right side, explore first element. Right side, explore first element. Once more you see. Right click on third ladder where you want timer, function block. In function block, right side, explore first element. Can you see? I have explored first element. You can go to the timer. You can see counter, timer, trigger, many things are there. Timer you have to explore. In timer, you have to take TOM, correct? On delay timer, enter. It has come. So timer you have taken here. I hope you understand. Now, this you should note down, because when you will make, parallelly we can't make, so you should understand. When you will make, you can see your notebook. To this timer, you need to give 3 addresses. Means you can say 3 configuration it requires. Above timer, you can see this one, above timer, left side of the timer, and right side of the timer. Let me start. Above timer, give any name, click outside, make it okay. Let me show you. Above timer, give any name. You can type any name here. After giving any name, click outside. You see, I shall do that. Click outside. This will be appear. Be very clear. Don't make any change here. Do not make any change here. Above timer, give any name, click outside, no change, make it okay. No change, make it okay. Is it done? So above timer, give any address, click outside, no change, make it okay. Right side, you see this right side. Just after just right side of the timer, you have to click. There again, we have to give some name, any name you can give. Click outside again. You see this one is important. Right side, give any name, click outside. This time you have to make change. Here you have to make time, T-I-M-E, because accumulator has to show time. So here you have to make time. Do you understand? Right side, give any name, click outside, this will come. Make it time. Type should be time. Make it okay. Done. I have seen people get confused while making program. Remember, above timer, give any name, click outside, no change. Make it okay. Right side, give any name, click outside, make it time. T-I-M-E. Type should be time. Left side. 10 second, right? It has one syntax. Syntax can get changed in different way. So it is T hash 10s. See this one. Can you see this? T hash 10s. If it is 5 seconds, T hash 5s. Like that you have to put. It won't accept only 10s or 5s. Fine. So now we have made this program. What you should do, you should first type this. Everyone make this. Then I shall tell you how to execute. Everyone make this program in your software. Do this, please. Is it done? Have you made this? After making this program, you have to execute it by login run. First, you should do login run. Login run. After login and run, you have to start I0, correct? So you have to double click I0. I hope you remember yesterday we had done double click I0, control, function, F7, correct? So you can see the timer will run, output is on. So what we have to do, we have to press I0, we have to double click I0, control F7, the timer, the output and timer will start running. And you check, it would be one problem you will face there. The problem is the timer finishes 10 seconds and it repeats itself. Means your output is not off. Your output does not get off after 10 seconds. I shall tell you why. You are running this manually, right? And you are using, you have to use push button, correct? So what I have done, here you can see I0. I0 I have pressed, means push button I have pressed, but I have not released it. Release means it will be off, right? No, when you release push button, it should be off. So I have not switched off this push button. Push button is continue pressed. So after 10 seconds, it goes, it breaks, and again I0 starts the process. So when you have to check your program in ladder, your push button I0 should be on and should be off also. So I double click and will do control F7, and now you will see after 10 seconds, it will switch off Q0. Right? So what do you understand? If you are going to check your program in ladder, then your input should be on and should be off as well. If you won't switch off your input, that input will be continue on, correct? So that done bit will come, will break, will go, again your output will be on. So your output, sometimes you won't be able to see that it is getting off. So better you operate your input twice, on and off. Fine. Everyone, if you have finished this ladder, log out, go to visualization page and make I0 button and one output Q0. You have to design two things. One switch you have to design I0. This time it should be tap variable. Yesterday in input you had taken toggle variable. You remember now? It was toggle variable percentage IX 0.0. This time not toggle but tap variable TAP. Below that you will find. There you have to give address percentage IX 0.0 because it is a push button. And one output you have to design. Do that. Log out, left corner, third element, visualization, right click, add object, give any name, okay. Here is your visualization page. In visualization, you have to take one switch, double click, color, alarm color, any color we can take. Then variables, we have to go to change color. What is input address? What do we have that? Percentage IX 0.0. Then we have to go to input. You see this one, tap here. Tap variable I have clicked. And here I have to give input address percentage IX 0.0. Okay. Done. We want one output, we can take any design, no problem. Double click, color, alarm color, variables, output address, percentage, QX 0.0, and enter. Make this, please. Everyone, make this. One switch and one output. Did you make it? Did you make it? So one switch and one output. Switch is tapped variable. Now you see, if I run this login run, see this, everyone, you please look at this and check. When I press the start button, you will see mouse left key I am going to press, or on laptop you can press your right key, right? No. When you press this and leave it, you can see this time you don't need to operate switch two times twice. You will press, it will be on, leave, it is off, and you see the output is on for 10 seconds. After 10 seconds it is off. Once more, you see push button. When I press, it will be on. When I leave, push button will be off automatically. You see, press, release, and Q0 is on. It will be on for 10 seconds. Done. Now we shall learn how to visualize timer, how to make a timer in visualization. That is very nice. And let me tell you one thing. This visualization is a kind of SCADA software. You've heard about SCADA, right? So this is kind of SCADA design we do. And this is facilitated, we get facility of SCADA in this software. Like you go for Mitsubishi, Allen Bradley, Siemens, they don't give you the same software for SCADA and PLC programming, but here you will find PLC programming and SCADA design both. So here you see, we can display timer also, but what we have to do for that, see this. I hope you understand this. For timer visualization, you have to take a new ladder. Be very clear about it. And if you are interested, you should write down also, because you will forget this after this training. So better you write down this. So what we are going to note down? Visualization of timer. Visualization of timer. So for visualization of timer, you need to modify your ladder first. You need to modify your ladder first. So first we shall write down ladder modification. In ladder modification, you write down. Take a new ladder. Write down. Take a new ladder. Take a new ladder. Right click on that new ladder. Right click on that new ladder. Right click on that new ladder. Box with EN. Box with EN. Box with enable. Box with EN. So right click on the new ladder. Take box with enable, and you see what will come. See, write down. And block will be appeared. And block will be appeared. And block will be appeared. Next, you write down. Click on and. Click on AND. Click on AND. And. So you see, look at this screen. I click this and. You don't do this parallel. You just note down first. So I click this and you should write down. Click on and type time underscore to TO2 underscore word WORD. Did you understand? So take a new ladder, right click on that ladder, take box with enable and block. As AND block comes, click on AND, write down time underscore to underscore word WORD and click outside. As you click outside, you will get two elements, left side and right side. Left side, you have to give your accumulator address. Be very clear. Left side accumulator address of your timer. Write down. Make this block on your notebook. And left side you write down accumulator of the timer. Accumulator address of the timer. And what do we have accumulator address? In my program, I have taken A. You can take any name here, right? So whatever name you have taken as accumulator of the timer, that name you have to give here. Correct? So whatever name you have taken as accumulator in your timer, that name you have to put left side. Right side, variable address. Right side, variable address. In Codesis software, variable address is percentage MW1, MW2, MW3, you can take any. So percentage MW1, write down please, write down please. Once more, I shall repeat the steps for visualization in ladder. Take a new ladder, right click on that new ladder, take box with enable, EN. AND block will appear. Click on AND, type time underscore to underscore word. Click outside, two elements will come. Left side, accumulator address of your timer. Right side, variable address. In Codesis, it is percentage MW1, MW2, MW3, whatever. So here we have taken. So this is for one timer. If you have many timers, suppose 3 timers. So 3 accumulator addresses you will have. You can't take the same address for all 3 timers. So you will take suppose A, B, C. So 3 blocks you will have to take. And 3 blocks, left side A, B, C and right side percentage MW1, MW2, MW3 like that. So you have to make this conversion block, time to word conversion block for each timer. Now we go for visualization. Huh? So now you write down for visualization. Write down please. For visualization you write down. Click third last element. Write down. Click CLICK. Click third last element. Here it is. You see 1, 2, 3. Click third last element, in bracket you write down meter, 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 meter. Click third last element in visualization, click third last element meter. You see, I click it. From this meter, draw a big rectangle. From meter, draw a big rectangle. Write down please, draw a big rectangle. Here I write. Here I draw. You see this. I click and draw. Leave it. As I leave, this block will come. Once more. Click third last element meter. Draw a big rectangle through this. Leave it. One block will come here. Here you have to go to, write down, variable scale. Variable scale. Write down variable scale. Variable scale. Click it. So this will come, you see. Here you have to give your things. Write down please, start, scale start, you write down scale start, what we have to write down. In scale start, you have to give 0. We have to start from 0, okay. So scale start is 0. Scale end. Scale end will be maximum time, means how, what number you want to show. So maximum 10 seconds, I shall give 10 more. Did you write down? Scale start 0. Scale end, maximum time. Third one, main scale. Main scale is like, how do you want to show? 1, 2, 3, 4, 5, 6 like that, or 2, 4, 6 like that? That you have to decide. I have to give 1, 2, 3, 4. So I make it 1. Main scale 1. Main scale 1. Other you don't do, directly you go to last variable. Write down last one. Variable. Don't disturb other things. Go to last variable. Variable. In variable, you write down your variable address. What we had taken variable there, ladder percentage MW1, correct? Percentage MW1. So this is for one timer. For different timer, you have to make different. Okay. Okay. Let me tell you once more. In visualization, click third last element meter. Draw a big rectangle. As you leave, this will come. Variable scale, in variable scale, scale start will be 0, scale end will be maximum time, main scale will be 1. Last variable, what you have to give? Percentage MW1. Have you written this? Variable percentage MW1. Actually, you divide this by 1000 also. I had forgot. So divide by 1000. It should be variable percentage MW1 divided by 1000. Divide it by 1000. Further, I shall tell you why I have divided. This is actually scaling. We have scaled it. So percentage MW1 divided by 1000. Further, I shall explain this. Okay. Now let me show you so that you can also make it. Login, run. See this please. Login, run, and I start it. You see. Wait. I think I didn't divide. 100 only. You see, I made mistake here. I have divided by 100. I have to divide by 1000 actually. That's why it was running continuously. So 1000 actually. 1, 2, 3. Yes, 1000. Let me show you. Start. You see this. Output is on 3, 4, 5, 6 like that. So now you can monitor, and it is off. So last signal comes, it breaks the latch, everything is off. Timer is also off. Reset. So you have to make this place. So start from your ladder, please, everyone. You have made this program. You go to that. You have made this program. You go to that. Take one last ladder, and you have written down. Follow that, please. Make this, please, everyone. Make visualization. Follow the steps you have written down, and you will get it. Did you finish it? Have you made this meter? Did you make this meter? If you face any problem, you text me. Okay. Once more, I shall repeat how to take timer. Once more, I shall repeat how to take timer. So wherever you have doubt, you can clarify this time. I hope you don't have any problem to take addresses and Coil, Latch, no problem. See how to take timer. If I delete this, I want timer on third ladder, so I shall right click on third ladder. Correct? Right click on third ladder. Where to go, you see here. Where to go, you see here. Function block. So to take timer, we have to go to function block. Right click on the ladder, function block. I click this function block. In function block, it will appear like this, you see. So this is left side, right side. Right side, you have to explore first one. Can you see this? First one, first plus, second plus, third plus. First one. Now here you see, in that it will appear like this. There you have timer. Can you see this timer? You can double click or you can explore it. Then you have TOM. You can double click this or you can make it okay, it will come. So it will come like this. Take this place. If you have not taken, you take this place. Right click on the ladder, function block, explore right side, you explore first element. There you will have timer. You explore that and TOM you select. I hope you got this. Fine. After taking this timer, you have to configure three things. Above timer, you see, above timer, click it, give any name you can put here, and click outside. I will have to change this so that you can see what will happen. If I change the name, you see, any name I have given. I click outside. and this block will come. You make no change. Above timer, click out, give any name, click outside, no change, make it okay. Right side of timer, you see. Right side of timer, give any name, like I change it, suppose D I give, or any name you can give. Click outside, but this time, what you have to do, this time you have to make this time, T-I-M-E. This time you make it time. Okay, got it? So above timer, give any name, click outside, no change, make it okay. Right side, give any name, click outside, make it time. So you can see, if I take the cursor, it will be time. But here, if I take the cursor, it is TON. So there we didn't make any change. Here we have made change. And preset value format they have given, syntax they have given, T hash 10s. So here you see T hash 10s. I hope you understand that. I hope you understand it. Make it please. And people who have made this already, if you have finished this visualization, you take save as file of this program. Save as. First you save your program, then you take save as file and modify the program for last one, 3 timers program. So modify this program for 3 timers. We have made red, yellow, green program, red, yellow, green, last one, that you make. So better you save this program, take save as file, make modification in that, and make it fast. We have very less time left. So make that traffic light program, red, yellow, green. In that, 3 timers are required. So 3 timers will have different name. 3 timers accumulator will have different accumulator address. 3 time to word block will be required. In visualization, 3 meters will be required, correct? Do that. You can see for 3 timers, I have taken here 3 blocks, conversion block. For 3 timers, I have taken 3 conversion block, timer 1, timer 2, and timer 3. So first timer, I have taken B as accumulator, second is A, third is C. You have to check yours. You have to check yours. What have you taken in your accumulator that you have to give here? And right side, you can see MW1, MW2, MW3. In visualization, now we need 3 meters. And 3 outputs also. The time to word you can take in separate ladder also. It is not necessary to take in single ladder only. You can take 3 new ladders, and in 3 new ladders you can take time to word, time to word, time to word, percentage MW1, MW2, MW3. So you can take it separately also. No need to take in single line, single ladder. If you have taken same address for 2 timers or more timers, then better simply you go and change the name. Change the name, and the same name you have to use. If you are going to change accumulator name, then you have to give the same name in time to word also. Like in ladder, if I show you, here you see what I have done. Here I have taken B. Initially it was A, right? I made it B. So here also I have made B, you see. So here it is A and C. If I make change, suppose I don't want A here, but I want D. Suppose I have repeated it. A I have taken several times. Then I shall give here another name. We'll click outside. We'll make it time, TIME. And then I shall change here also. Like I have changed second one, no? So second time to word I have to change here. D, it would be D. That is it. Okay, I think time is up now. So let me show you this. See this. When we press the start button, rate should be on for this 10 seconds. If you have not finished this, this is your homework. And hello. Hello, see, my timer is not running. I made mistake here. D. D. Fine. So what you have to do, You have to make this. This is your homework. And one more example I shall give you as homework. I think it's better. You finish this one. So you finish this with visualization like this. You have to send the screenshot. So ladder and visualization both. And you can ask your doubt if you have, and we shall go through poll question now.
All right, sir. We will go to the next poll question.
Yes. So this problem was because of I have taken same address for two timers. That's why my timer was not running. So you should change the timer name. You should not repeat the same address. Now we go for poll.
Poll question is on the screen. I hope everyone is able to see it now. All right, the poll is completed. The poll questions are on the screen. So if you need to go through them, yes.
How many types of timer do we have? Obviously, we have four types: on delay, off delay, pulse, and RTC. So we will have four types. A. What is the address? Address we have already used, percentage IX 0.0, right? Percentage IX 0.0. Okay, it is done. So we shall bind up.
Yes, sir. All right. So any last comments for the day, sir?
Tomorrow we are going to learn here counter, and tomorrow it would be important topic, physical inputs, outputs, digital input, output, what we use in industry in real time, that I shall show you here also. We'll bring PLC, we'll do wiring, and we'll show you the things running, and we'll interface real-time software, real-time PLC, real-time communication we shall do. So it would be a bit interesting tomorrow. Thank you.
All right, then we will see you tomorrow afternoon. And just to inform you, we will be having the final MCQ tomorrow evening. So please be present. Thank you so much. Yeah.
Thanks.